as we explained on Friday, in order to graph these lines, you are always going to start with your y-intercept. The y-intercept in this case is the -2. So this right here is your y-intercept. So you're going to plot that point to start. So you have a point right here at 0, -2. And then from that point, you take and apply your slope, which is this point right here. So you go up 7, 1, 2, 3, 4, 5, 6, 7, and then over 2, so 1, 2, and there is your 2 points. If you could do 3 points and by going down and left, we would appreciate that too, but in the case of this graph, you did not have enough points to go down and left. Connect your lines, and it's also important to note that there are arrows at the end of both of those lines because a line is continuous. Its domain is all reals. Therefore, you need arrows on it because it is greater than a segment. This one has answers on it. Okay, number 2.
Right, yeah, no, I still have the answers.
Yeah. All right, number 2, you have y equals -6x plus 3. So once again, you start with your y-intercept that is at 0, 3. Your slope is down 6 and over 1. So you plot your point, connect, and draw your arrows on your lines.
Later on, you're going to find it's really significant if you have a curve in the graph, even if you don't mean to put it there.
Yeah, so guys, what Mr. Mannion's saying is when you draw these lines, you want them to be straight. So what I always tell my students to do is take like their notes and use it to draw a straight line in on their homework. So you can use like the edging of your paper to draw in a straight line. Don't rub your hand like that, you might get paper. So we skipped 3. We're going to talk about 3 today. We're going to go over to number 4. So once again, your y-intercept is +1. You have to count up 6 and over 5. So that point would have been right there. If it's off the graph, like the case of this problem, then you have to do your rise and run backwards. So instead of up 6 and right 5, that is the same as saying down 6 and left 5. So you go opposite for both. So again, if one point's off the graph, you can go in the opposite direction. You can always check between your 2 points by going up the rise and over the run. And if you think about the words rise and run, what does the sun do? It rises, right? So think of sunrise And if you go running, are you going to run up a hill or do you want to run flat on a sidewalk? You want to run up a hill? You're silly, Abby. So when I go running, I try to run on the flattest possible path. So when you're running, you want to run flat. And if you're the sun rising, you're going up. So that's an easy way to think of rise over run. It's like the sun going up and the runner running on his path. Okay, and then number 5. We have 1/4 x plus 2. So again, you start at your y-intercept of 2. We're rising 1 and going right 4. Or running down 1 and left 4. Okay? And then the last one I asked you to look at was 7 on the back. So once again, you had a y-intercept. Now 7 was a little bit tricky. What number is being added here? No number, right? So where do you start, Zoe? Yeah, if there's no number, then we start at 0, 0. And then we go up 5 and over 3, or down 5 and left 3. So we are going to pick up where we left off in our notes. So we're still graphing those coordinate lines. So on Friday, when we looked at lines in the coordinate planes, one of the things we talked about to start the class was that slope. So you did these 2 examples on Friday, and we found our slopes. We talked about slope-intercept form, where y equals mx plus b is slope-intercept form. M is the slope of the line, and b is the y-intercept. So that gives you your rise and your run. You talked about this example right here, y equals 3/2 x plus 2. You talked about the 2 being your y-intercept and your slope being 3/2. We made a table of values. So is everybody okay with the beginning of the notes from Friday? So that means we're going to pick up with example 2, correct? So what's my y-intercept? And what's my slope? So Zoe, which one do you want to give me? Okay, what's my y-intercept? Awesome. So my y-intercept is -2. And that is the point we start the graph. We plot that point on the y-axis. So you're going to plot the point 0, -2. What's my slope? What's my slope? Zoe? Perfect. -1/2. So what does a -1 tell me? What direction am I going on -1? Good? Yeah, I'm going to go, so this in words is down 1 and right 2. So from my y-intercept, I'm going to apply my slope and go down 1 and right 2. And I can repeat that as many times as I want to give me a straight line. So on Friday, we kind of focused on making tables, and on Thursday, we can now sort of push away from that idea. If I didn't want to go down one and right one, what's the opposite directions I could take my slope, Madison? Perfect. So you could kind of think of the negative as flipping spots. Instead of the negative being up top to go down, now the negative's below to go left. And graph your line. Okay, example 3. Sure, Sierra. Good. Sorry, just a little louder for me. Perfect. That slope is -2. And what's the y-intercept? Perfect. So on my graph, we start at which one of those points? Where do I start? At the -2 or the 4? Madison? The 4. So I'm going to start at 0, 4. And my slope in words. What does a -2 in words mean? Am I going down, up, left, right? Zoe? Down how many? And then how many do I go to the right? 1. If I wanted to go in the opposite direction, Madison? Perfect. So we can either go down 2 and right 1, or up 2 and left 1. Here. Now, is this line increasing or decreasing? Are the points getting bigger or smaller? Zoe? They're getting smaller, so that means the line is decreasing. Excellent. So remember back in the day, probably in like December, we talked about increasing and decreasing. We also, and you saw in our homework, we skipped 3 and 5, or 3 and 6, because those are what we call special lines. The slope of a horizontal line. So a horizontal line, is that going to be up and down or left and right? Left and right. So a horizontal line is left to right. The slope of a horizontal line is special. It is 0. The slope of a horizontal line is 0. Its equation will always be y equals b, where b is once again your y-intercept. The equation of a horizontal line will always be the equation y equals b. Because if the slope is 0, what's 0 times x? 0. So it zeroes out or goes away. The equation of a horizontal line is always y equals b because the mx part is 0. Does that make sense? So if a horizontal line is left to right, a vertical line is up and down. What would the rise of a line being up and down be? Go ahead, Madison, what do you think? What? The rise of an up and down isn't 0. The rise of an up and down might be anything, right? It could be 1, 10, 15, because it's going up and up and up and up, or down and down and down and down. So where would the 0 actually be then, Madison? If the rise isn't 0, where's the 0? Am I running anywhere? So my run is 0. So my rise could be any number. The run or the slope then would be a number over 0. Can we divide by 0? No. So if you try to divide by 0 in math, does anybody know what that's called? What do you think, Dominique? Not no solution. It's a little different. It's along that line, but no solution means that you tried and it didn't work. So this is, what do you think? That's the other extreme. The word solution is not part of this. No solution in this. The opposite of a definition. So the equation, anybody have a guess at what these equations are going to be? Madison, what do you think? It is going to be an x. You're exactly right. And you're exactly right. You can't really know what it's going to be. It's going to be whatever that number was. It's going to be x equals a number. So sometimes, instead of putting the number or what you call a hashtag symbol, we write x equals a. This is a good one. I used it last period. There was a fly. Okay, the horizontal and vertical lines have easily recognized equations then. Horizontal and vertical lines have easily recognized equations then because there's only how many variables? How many variables are going to be in these equations? 1. Okay, write the equation for both a horizontal and vertical line containing the point -4, 3. So here's what I would do. Go plot your point. Now, let's start with horizontal. A horizontal line goes what direction? Guys, I'm not going to shout over you. I can stop and wait for you to finish your conversations. Or we can do this. A horizontal line goes what direction? Dominique? Not diagonal. Zoe? Left to right. So draw in the horizontal line. Because the rise of a horizontal line is 0. What's the y-intercept of that graph? What's the y-intercept of that graph? What's the value? The y-intercept is the point where the graph crosses the y-axis. What y value does it cross the y-axis? Abby? Yeah, it's at 3, right? So a horizontal line is y equals the y-intercept. The y-intercept, Abby just told us, is 3. So the equation of the line is y equals 3.
Please put the masks on the right way. They're all like 4 below noses right now.
A vertical line goes what way? A vertical line goes what way? Up and down. So take your hands, make vertical lines. Put your hands up and down. Vertical, up and down. Horizontal. It's like, what's that in baseball? Safe. So make a safe if you play baseball or softball. It's kind of like a touchdown in football.
All directing airplanes back in the bag.
All right. What equation does a vertical line start with? Zoe? Yeah. So if you're asked for a vertical, it's x equals, what x value does that red line equal everywhere? What x value is that red line always equal to? Count on, go. You can go even touch the board if you need to count, but -4. Someone said it. Yeah. So what do you notice about each of these equations and what they're equal to and our original point? So